Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is special array with x elements greater than or equal to x. Okay, so you will be given an array nums of non-negative integers. The given array nums is considered special if there exists a number x such that there are exactly x numbers in the nums array that are greater than or equal to this number x. Okay, so I know it sounds a little bit too wordy or too much of wording there and too much of complicated sentence, but it is basically saying you, let's say there is a number 3 in the array, so then there will be exactly 3 or more number of elements which are greater than or equal to 3. If that is the case, then 3 is considered as a special number. Okay, and we will say that uh, nums array is special. Okay, so if you know let's say a array is there and the numbers are something like 3, 5, 6 and 7. So if you consider for 3, how many numbers are greater than or equal to 3? So 3 is greater than or equal to 3. Then 5 can also be included, 6 can also be included, 7 can also be included. So in total you can say that there are 4 numbers which are greater than or equal to 3. And according to the definition, x will be a number such that there are exactly x numbers in that array that are greater than or equal to x. So there is a little you know extra here. So if you remove 7, so how many numbers are less than greater than or equal to 3? Then it comes out to be 3, which is exactly the number we wanted. So it is the answer. Okay, you can x can be any number, and if and it is also mentioned that this x that you will be taking need not to be any element in the given nums array. Okay, so it is, we took the example such that the element x here was 3. It was a number in the given array, but it is not necessary. Okay, so you will see in the first example that they have given, return the x if the array is special. Okay, otherwise you should return -1. And it is further stated that it can be proven that nums is special if nums is special, then the value of x is unique. Okay, so if at all this array is a special array, then x value will be unique. So let's take the very first example. The given input array is 3 and 5 only, so you can remove this 6 only for a moment. And if you take 3 as your x or 5 as your x, it will not satisfy condition for the nums array to be special. If you take x as 2, So there are exactly two elements in the given nums array that are greater than or equal to 2. So if x is taken as 2, your condition for x, is satisfied, that there exists a number, uh, that the number of elements greater than or equal to that number is equal to that number. Okay, so if you take x equal to 2, there are two values 3 and 5 that are greater than or equal to 2. Okay, so that is how things will, we will approach this problem or check for the value of x. Okay, and let's have a quick look at the constraints before thinking of an approach. So according to the constraints, the length of the nums array will be varying from 1 to 100, and elements will be varying from 1 to 1000. Okay, so let's discuss the approach. How will we be solving it? So it will be a little easier for me, and it will be taking less time of, less time to make you understand the approach also, if we take the code to the board. So let's take it. Let's zoom in a little bit. Yeah, I think it should be visible enough. So what we are doing here is, firstly, we will be wanting to have all the frequencies of every number in the given nums array. Okay, so we want frequencies of every number. Okay, so I will tell you in a little bit why we are needing these frequencies for. So, and there is a little thing that you should be keeping in mind, that for the number to be a, valid x number, according to the problem statement, that there should be exactly x numbers which are greater than or equal to x. Okay, so the numbers which are larger than the size of the current array uh, can be very well, ignored, you can say, or maybe you can say they can be it would be good to say that they can be kept to size only. Okay, let's say size of the given nums array is 3. Okay, and if you are experimenting the value of x to be 3, then you are only concerned with, you know uh, elements greater than or equal to 3 appearing exactly 3 times. So if let's say there is a number 4 or 5, so it can be easily kept to 3. Okay, so that's why while taking the frequencies of the numbers, we will cap those numbers to a maximum, you know number size. Okay, and for the frequency array size, we will take one larger than the size of the numbers. Okay, and now what you will be having is, you will be having frequencies of all the numbers, okay, kept to size. Okay, which is the number of elements in the nums array. Then what you will be doing is, since you will not be checking for the 0, x cannot be 0. Why? Because then there should be exactly 0 elements equal to or greater than 0. Okay, which cannot happen, because, you know if you see the constraints, numbers in the given nums array are not equal to, are from 0 to 1000, and the length of the nums array is at least once. Okay, so there cannot be 0 numbers greater than or equal to 0. Okay, So that's why, starting from the size of the nums array, we will run a loop from right to left direction, and then check, keep a running sum. So this number greater than or equal to the current number is just a running sum. Okay. To check how many numbers are there that are greater than or equal to the current number. Okay. So this index is nothing but the current number that we are checking, that we are considering a valid candidate for x. Okay. Current number, or you can say valid candidate for x. Then if at any instance it happens that the number of elements greater than or equal to the current number, or the index is equal to that number or index, then we can say that okay, we have found our x and we will return it. Okay. And if in this entire process you are not able to find any x, so then you can very comfortably say that okay, there are no such numbers which can be considered as a, as a x. Okay. And you will return -1 in that case. Okay. So this is just a running sum. No, we are making use of running sum. Running sum is just like you are adding values as you are traversing them. Okay. And this frequency array was needed in order to, you know get the running sum, or the number of elements greater than or equal to the current element. Okay, this frequency will help us in that. And I think it is also pretty much clear to you why we are capping the numbers to size only, because a number cannot, the frequency of a number of elements greater than or equal to the current element cannot be greater than the size of the array. Okay, so it is wise to cap them to the size of the array. So that is why. And if you talk about the complexities, time complexity wise, you can say that it will be order of n. Space complexity wise, you can say that it will also be order of n, where n is the size of the array. Okay, so n is equal to size. So linear time complexity and linear space you are utilizing. Okay, so this is how we will be solving this particular problem. If you are still having any doubts or any queries in general, then you may ask them in the comment section. I hope this video solution and this solution walkthrough added some value to your journey of owning your DSA skills. Until then, keep practicing and keep solving problems. I will see you in the next video. Thank you for watching.